Today's lesson's called the scalar equation of a plane. Okay, vector equation and parametric equation were good, but scalar equation is even better because it was totally algebraic. Okay, the reason I didn't like parametric form, can I talk here, please? Parametric form of an equation is okay. What's the problem with it? Yeah, for like one plane you have 3 lines, which I don't like, or 3 equations, right? Which is very complicated. What we're going to do today is we're going to make a plane have 1 equation, which is nice, which is what we want to have. Okay? So we're going to say the scalar equation of a plane is AX plus BY plus CZ plus D equals 0, where the normal vector equals ABC. Okay, so if you have a normal vector to a plane, you can get the scalar equation of the plane, which is nice. So you find the normal vector, and then we're going to find a point on there to solve for D to plug it into the equation. Now, how did we find a normal vector again? I'm going to pick on Nate this morning, because as I was coming into school before 8 o'clock, Nate was sitting there flipping with his calculus book open. He wasn't actually doing his homework, okay, but he was thinking about maybe one day doing his homework, though. Nate, one of the questions came up and they wanted a normal, okay, or something like that. How did we find a normal then? Do you remember how you would find such a thing? Nate, all that build up and nothing. Maybe back to last unit, how do you find a normal? How do you find a normal? Cross product, okay, that's what we're going to end up doing here, okay? So we're going to say, remember that the normal vector you guys in 1 minute, please, is perpendicular to the plane. And is found using the cross product. Okay, what vectors would we be crossing on a plane? What vectors would we be crossing? Yeah, so the two direction vectors that we have, right? So when we're given 2 direction vectors on a plane, cross them, it's going to give us a normal, and we can get the scalar form. Scalar equation is nice because there's only one line, as you can see here. That's it. Like that's totally algebra, x, y, z, and a number. Right? Here we go. Example 1. It's going to say, find the scalar equation of the plane. With point P4, -1, comma 3 with normal sorry. Thank you. All right. Here we go. So simply enough, what's the A and the B and the C in this equation going to be? Okay, stay awake here, guys, please. Go ahead. 352. So we're going to have, the equation's going to look something like 3x plus 5y plus 2z plus d equals 0. Okay, that's what our equation's actually going to be. Okay. Does someone want to be brave and hazard a guess on how I might find what the d value happens to be? Not you, Michael. Someone else. Amy, go ahead. Very good. So we're going to sub x equals 4, y equals -1, z equals 3. So you're going to get 3 bracket 4 plus 5, -1 plus 2, 3 plus d equals 0. That's right. Try to keep it right. So all we're doing there is we're just subbing in different values when we solve for d. Now this is neat. I know you guys don't think it's neat, but I think it's neat. I think this is fabulous, in fact. Okay, and it's sort of weird when you think about it. You find something normal to the plane that's going to give you the equation. That's cool. 3 times 4 is?
12.
Thank you, good. 5 times -1 is? 2 times 3 is? Okay, 12 minus 5 is 7. I have 13 plus d equals 0. D is going to be -13. Therefore, the scalar equation of the plane is 3x plus 5y plus 2z minus 13 equals 0. All right, here we go. Questions, fears about that before I keep going? All right, here we go, example 2. I'm going to put a star and a heart beside this question. And Michael and I are going to wander to make sure you can do this. Okay, Michael, so it's time to wander. Okay. Example 2 says, find a vector, parametric, and scalar equation of the plane found by the points A is 2, -3, 4, B 1, 6, 1, C 0, 8, 2. Okay, so what I want you to do is I want you to find the vector equation of the plane, the parametric equation of the plane, and the scalar equation of the plane. My advice to you, if you have a hard time getting started, is to think back to a regular vector. We'll start with that. What do you need to make a vector equation of the plane? That's right. Two direction vectors in the point. Okay, so you're going to make 2 direction vectors. So think how to do that in the point. Once you have that, you're going to go to vector equation of the plane. Then you're going to go to parametric. Then you're going to go to scalar. Okay, you're going to try your best. You can do it. Is that too much for the next example? Do this? What do you mean no? You can do this. Do you want example 1b instead first? No, you can do this. You guys are calculoids. Goodness gracious. I'll tell you a few jokes here while you're working on that.